Alright, so in order for us to appreciate the function, we're going to start with one statement. And the statement is at rest or movement are inhibited. For you to move, so for movement to occur, there is need for you to inhibit what is inhibiting movement. I'll let that just settle in. So another way you can put this is, in order for movement to occur, you need to lift off the inhibition. Now, once this happens, then of course movement can take place. So the one that is suited for this is known as the direct pathway. So the direct pathway inhibits the inhibiting of the movement, or it lifts off the inhibition. Alright, secondary to this, you see that there is need to suppress other movements. So you only want the movement that you want to happen. So in order for you to do this, you use the indirect movement. Alright, so in this case, you are stimulating rest in these muscles, so to speak. Alright, awesome. So that's what it's all about. It's about lifting off the inhibition so that something can occur. And for those movements that you don't want to occur, you want to stimulate state of rest. Now, we're going to start the direct pathway. So in the direct pathway, if this is the cortex, okay, I'll draw a red line to make sure. If this is the cortex, I said we'll have the striatum, alright, and then the striatum is going to have crosstalk with the GP, so that's the globus pallidus. Then we have an internus and externa. This is the striatum. And then of course we're going to have our thalamus. So this is the thalamus. Now I'd like to introduce you to some terms and a few of the neurotransmitters. The first thing that I want to introduce you to are tonic fibers. So the word tonic means constant release without stimulation. So it will constantly release something even when there is no stimulation. In this pathway, this being the cortex, motor cortex, we will see that there are some of the fibers that are tonic. The tonic fibers are the fiber that comes from the globus pallidus internus and goes to synapse onto the thalamus. So because it's coming from the globus pallidus and it's going to the thalamus, we are calling this the pallidothalamo. Alright, this is the pallidothalamic fibers. Now this guy over here constantly releases GABA. So this guy here is GABAergic, and we know that GABA is an inhibitor. Alright, now the fibers that come from the thalamus and go to the motor cortex, these ones are excitatory. So what you have at rest is you have a tonic release of GABA, and because you have a tonic release of GABA, you see that you are not able to excite the cortex because the excitation levels of the thalamocortical, alright, thalamocortical, you see that these thalamocorticals are actually inhibited. Alright, so we have one inhibitor here, which is the pallidothalamo. So according to our statement of what movement is, in order for us to make sure that movement occurs, because what is happening at rest is that we have a tonic fiber known as the pallidothalamic fiber inhibiting any movement. So in order for movement to occur in this by this direct pathway, we need to inhibit this inhibitor. Alright, so this guy is our goal. This is the guy that we want to inhibit. Alright, so the system is made in such a way that this can actually happen. The fibers that will come, by the way, this is glutamate. The fibers that will come from the cortex, alright, so you think, alright, first of all, you're going to think of what you want to do, and then the thought of the motor movement you need, and efference, just like we were talking about in the other video, will be sent to the striatum, and this is also glut, and therefore it's excitatory. So you think and you stimulate the motor areas that you want to have the descending fibers happen, but as you are doing that, there is a stimulation of the striatum, sending it exactly what you want to do. Okay, so in order for you to ensure that what you want to do happens, first of all, these fibers coming from the cortex going to striatum, which are known as corticostriatal fibers, are going to stimulate the striatum. All right. Now, in the striatum, the type of nuclei that are there, okay, type of nuclei that are there are GABAergic. So you see where the story is going. So now we have a way of stimulating something that can inhibit our inhibitor. So from here, this goes right to the inhibitor in the globus pallidus internus. So these, of course, GABAergic, and the name is striatal pallidus because it's coming from the striatum going to the pallidus area. So you think that's number one. It goes, of course, to the motor cortex. That's number two. But again, it also stimulates the corticostriatal. These release glutamate onto the striatum, and they stimulate the striatopallido. Once the striatopallidos are stimulated, they release GABA onto the globus pallidus interna. So if they're releasing GABA, it means they are inhibiting the pallidothalamic fibers. So if they inhibit this, then we have finally inhibited the inhibitor. So once we lift off this inhibition, we are going to then allow the thalamocorticals to stimulate the motor cortex. Listen to what I'm using. Again, the terms. You think, and then the corticostriatals receive stimulation. These are going to stimulate the striatopallidas, and once the striatopallidas are stimulated, they are going to release GABA on the globus pallidus internus. Once GABA is released there, it is going to inhibit the pallidothalamos. Once these are inhibited, it will mean that they have lifted off the inhibition that was happening between the thalamus and the cortex. Therefore, whatever you are thinking it should happen will now happen, because the thalamocorticals will stimulate the exact areas of the motor cortex where descending fibers should emanate from and go to the particular muscles that you need to have movement in. So that is how the direct pathway works. So again, what you need to know is that the inhibitor here is our tonic guide, the pallidothalamic fiber. Maybe a few things that you should know is that this pathway not only enhances motor movement that were initially stimulated, but if there was a lesion in this pathway, your desired actions will not be chosen. So if you want to lift your finger, you think, let me lift my finger, that will not happen. And because what you want to happen is not happening, it is hypokinesia. So you will notice hypokinesia or reduced activity, also known as bradykinesia, or no movement at all, akinesia. All right, akinesia. All right. So akinesia is a difficulty in initiating movement or increased spontaneous movement. So these are going to be seen once the direct pathway is injured or insulted, or as the pathologists say, or something happens to it. Okay,